In this video, we will give an introduction to inferential statistics focused on definitions and big ideas. What is inferential statistics? We present a basic working definition. Inferential statistics is the science of analyzing and testing sample data for the purpose of making decisions or drawing conclusions about an underlying population. Such conclusions are accompanied by a probability indicating our level of certainty or uncertainty in the results. There are several methods or tests used in inferential statistics. Some of the more common methods are regression analysis, which allows for investigation of a relationship between two or more numerical variables, confidence intervals, which are used to estimate a population parameter from a sample statistic, hypothesis testing, which looks for evidence of a false hypothesis, chi-squared testing, which looks for evidence of a relationship between two categorical variables, and ANOVA, or analysis of variance, which is used to test for evidence between one categorical and one numerical variable. ANOVA actually tests whether there's a significant difference among three or more means. Before we launch into descriptions of the various techniques for inference, we should consider how to use inference wisely and avoid some flagrant errors. First, understand your data. Conduct exploratory analysis to organize and summarize the data. Next, understand the specific question you want to answer. Statistical inference works well when you first decide what effect you suspect, design an experiment or sample to search for it, and then use a statistical test to weigh the evidence you obtained. You must also understand the specific requirements of the various methods. Essentially, the standard techniques require a simple random sample drawn from a normally distributed population. Finally, fit the method to your setting. Massaging your setting or your data to fit the only method you know is analogous to committing statistical malpractice. Fortunately, most of us are consumers of statistical reports as opposed to the creators of those reports. If we need to perform serious statistical tests, we usually seek expert advice. As a reader of statistical reports, we should concentrate on the big issues instead of the nitty-gritty calculational details. Does the study ask the right questions? Where did the data come from? How was it obtained? By whom? And when? There is no correct method for data haphazardly collected with a bias of unknown size. Is the sample size given? Larger samples make tests more sensitive. A finding can be statistically significant without being of practical importance. On the other hand, tests based on small samples may not be sensitive enough. Lack of significance does not mean there is no effect. It simply means we do not have good evidence of an effect. Does the report give a confidence interval so that you can see both the estimated parameter and how uncertain those estimates are? Are p-values given in tests of significance to help you see that the findings are not just good luck? And does the method fit the setting? Statistical software will happily fit a straight line to curved data. In addition, it is bad practice to search a dataset for suggestive patterns and then use the same dataset to conduct a test of significance. After finding suggestive patterns via exploratory analysis, the appropriate course of action is to design a new study to specifically search for the effect you think is present. In the next video, we will start getting into some of those calculational details.